Welcome to The Explainer. Today, we're diving into a massive, absolutely crucial shift in mindset. We're talking about the critical difference between a hobbyist who just kind of crosses their fingers and hopes a machine works and a true professional who guarantees it. So let's unpack the professional's blueprint for pre-operational checks and machine setup. Look, this isn't just about blindly ticking boxes on a clipboard. It's about mastering the absolute most important minutes of your job, and those are the minutes before the engine even turns over.
You know, the amateur approach is literally just turn the key and go. And sure, it feels fast in the moment, but it's a massive gamble. It inevitably leads to incredibly dangerous and wildly expensive consequences. We're talking seized engines, work site accidents, or, honestly, even worse. On the flip side, we have the professional approach, which is systematic preparation before starting. A professional uses the exact same systematic approach every single time. It's really not about having decades and decades of experience. It's about relying on a rock-solid, reliable sequence rather than guesswork. That is how you catch a catastrophic failure before it ever happens.
To get us there, we're going to break down this professional blueprint into 4 core pillars. 1. The foundation. 2. The lifeblood. 3. The gatekeeper. And 4. The transformer.
All right, let's jump right into pillar number 1, the foundation, which focuses entirely on the pre-start walk-around.
Like we said, the most critical minutes of operating heavy machinery happen before you even touch the ignition. A professional walk-around follows a very strict sequence. First up, you read the standard operating procedure, the SOP for that specific piece of machinery. Second, check all your fluids. Third, confirm every single guard is securely in place. And fourth, test the controls, especially things like the emergency stop, well before you load any material. Basically, you start at one point on the machine, usually right at the operator's position, and you just move around it in a single continuous direction. Professionals never guess their way around a machine. They execute these exact same steps in the exact same order every single time.
Now, while you're doing this walk-around, you have to engage all of your senses. You aren't just giving the machine a casual glance. You actively look for weeping seals or tiny little pools of fluid underneath. Once it's running, you listen carefully for any weird new rattles or sudden changes in the engine note. You smell the air for burning oil or maybe hot rubber. And you carefully touch, now obviously never near hot or moving parts, right? But you use your hands to check if a guard has vibrated loose or if a tire feels a bit soft. Engaging all your senses is the secret to catching those tiny, cheap-to-fix problems before they explode into dangerous, incredibly expensive failures.
Moving on to pillar number 2, the lifeblood. This is all about managing the machine's essential fluids.
Getting your fluid specifications exactly right is non-negotiable. Take the standard 2-stroke fuel-to-oil ratio of 50:1, for example. An amateur might just try to, eyeball this mix, pouring a quick splash of oil into the petrol and hoping for the best. A professional? No way. Never. A professional knows that the operator's manual specifies an exact ratio for a reason, and failing to meet it means you are completely destroying that engine from the inside out.
So if you need a 50:1 ratio, that literally means 50 parts petrol to exactly 1 part oil. To put that into perspective, for 5 liters of petrol, you need exactly 100 milliliters of oil. Just got 2 liters of petrol? That's 40 milliliters of oil. Calculating this math takes maybe a few seconds, tops, but it saves the engine from smoking, fouling, or just completely seizing up on the job. The takeaway here? Measure, absolutely do not estimate.
And hey, this exactness, it applies perfectly to your job planning too. Let's say your mower uses about 2 liters of fuel per hour, and you've got a solid 4-hour job ahead of you. A super quick calculation tells you that you're going to need 8 liters of fuel total. Now, if your tank only holds 5 liters, you instantly know, right then and there, you'll need to pause and refuel once during the task. Doing this simple math up front prevents the wildly embarrassing and potentially dangerous mistake of running completely dry right in the middle of a heavy task.
Okay, here we go with pillar 3, the gatekeeper. This is where you step up for spotting and tagging damage.
As the gatekeeper, you are actively empowered to protect the entire worksite. And here's a cool fact. A machine actually speaks a secret language to you, if you know how to decode it. A leak isn't just a random mess on the floor. Its specific color pinpoints exactly what system is actively failing. See dark oil? That points directly to the engine. Got red or amber fluid? That's almost certainly your hydraulics. Green or orange fluid points straight to your coolant system. And it's not just fluids either. You have to look for hairline cracks in guards, blades, or the frame. Because under heavy vibration, a tiny little crack can spread like wildfire in minutes. And a guard that fails no longer protects you from the spinning blades right behind it.
So let me put you in a real-world scenario for a second. You're doing your pre-start check on a heavy-duty mulcher for the day. You spot a small pool of oil directly under the engine, and you also notice the main blade guard is rattling loose. What's the call? Do you try to fix it? Do you ignore it and just get to work? Or do you flag it? Think about it. Well, a professional's answer is immediate. You flag it. You absolutely do not start that machine. Hitting the ignition could cause severe engine damage or instantly expose you to a fast-moving blade.
And how exactly do you flag it? You use the ultimate tool of the Gatekeeper, the Do Not Operate tag. Listen, this is not a suggestion. It is a strict, legally binding operational signal. It means the machine must never be operated until it is fully repaired and officially cleared by an authorized person. Ripping off or just ignoring an out-of-service tag puts lives at immediate risk. It is an absolute line in the sand for workplace safety.
But tagging it is only half the job. Once it's tagged out, you have to report it clearly. A poor report simply says something vague like, yeah, the mower is playing up. That helps absolutely no one. The poor mechanic has to start from scratch and guess what's wrong. A crystal clear professional report says, engine cuts out at low idle, noticed during pre-start today, tagged out. Boom! That instantly answers what the fault is, exactly where it is, when it was noticed, and what action was already taken. It gets the machine repaired so much faster and gets it back to work safely.
Finally, we've arrived at Pillar 4, the transformer. Let's talk about fitting ancillary equipment.
Ancillary equipment and heavy attachments essentially act like a giant multi-tool for your worksite. These attachments completely transform a machine's entire identity. Think about a compact loader. On its own, it has extremely limited function. But if you fit it with the right attachment, it instantly becomes a versatile powerhouse. Add an auger, and suddenly it bores fence holes. Add a mulcher, it easily clears out thick branches. Add a trencher, and it digs through tough soil. This is exactly why matching the correct attachment to your specific task is so critical, and why forcing the wrong attachment to do a job it literally wasn't designed for is incredibly dangerous.
Because these attachments are heavy, cumbersome, and inherently dangerous, fitting them safely is completely non-negotiable. Step 1 is absolute law. Isolate the power. I want to heavily emphasize this. The machine's power must be completely isolated. That means shut down, key completely removed from the ignition before the attachment is ever touched. You never, ever change an attachment with the engine running. Once the power is isolated, then you can safely line up the points, fully secure the locks or pins, connect any necessary hydraulic lines, and finally restart the machine and carefully test the attachment clear of the ground. Skipping that isolation step or failing to test it before diving headfirst into the work is exactly where devastating, crushing, or amputation injuries happen.
So there we have it. We've covered the systematic walkaround, managing the lifeblood fluids, acting as the gatekeeper with damage tagging, and the absolute rules for safe attachment fitting. You now have the complete professional's blueprint in your hands. So I want to leave you with a final, provocative thought to take directly onto your actual job site tomorrow. What warning signs is your machine giving you today? Are you rushing the turn of the key, just hoping for the best? Or are you taking those few systematic minutes to listen, look, and genuinely guarantee your safety? The machine will tell you everything you need to know if you just take the professional time to ask it. Thanks so much for joining me on this explainer, and I will see you next time.